signals like signal mask, signal actions, okay, child signal. So these are the things we discussed in the last previous session. These things we discussed in the previous section. So moving on to the next one, that is a sig set jump and sig long jump. Okay, so this is similar to set jump and set long jump API that we discussed in the previous session. Okay, previous module. So here it is. This is related to signal. Okay. Here in long jump and sig jump API, okay, sig long jump API. So here they are defined in POSIX 1 and in most UNIX system that is meant for supporting signal mask. Okay. So here you can see this is a prototype we use. So here we have two parameters. Okay. So sig set jump and sig long jump, they are created to support signal mask processing. Okay. So here you can see there are two environment variables. Okay. First parameter. Okay. So the first parameter is environmental variable. Second one is save sig mask. Okay. What is save sig mask is for? So save sig mask allows the user to specify whether a calling process signal mask should be saved to the provided env. Okay, we have this env argument. It tells okay whether which allows the user to specify whether a calling process signal mask should be saved on the provided env argument. Okay, so this save sig mask argument returns specified as non-zero. Okay, so which represent the calling signal mask is saved. And here in sig long jump, okay, here similar to the previous set jump, here also we have an environmental variable, and there is one more integer argument. Okay, so this argument ret underscore val argument specifies the return value of the corresponding sig set jump. Okay, so previously when we discussed about sig jump and long jump, okay, there also we had this return value. So this return value is corresponding to the previous one. Okay, so previous one it returns some return value. Okay, that return values is specified here. Okay, so it will be clear when we discuss the example. So look at this example. Okay. Here you can see sig long jump. Where is the prototype of that sig long jump? Is here. Okay. So here you have sig long jump. Okay. So this long jump API is usually called from the user defined signal handling function. Okay. So this is our user defined signal handling function. The name of this function is call me. Okay. So usually this sig long jump is specified inside user defined signal handling function. Okay. Then you have sig set jump. Okay, here. So here we have sig set jump. Okay, with the return value. Okay, we can see here. This is our signal mask. Okay, this is our return value. So this is our signal mask, and this is our return value. Okay, so let us go through this program. So this program clearly explains okay sig set jump and sig long jump. So So here you can see here, initially going to the main program, you have different structure, okay, structure members, okay. This member, there are structure sig action, there are two members action and old action, okay. Empty all the signal mask, okay. So for a processor, we will be having set of signal mask which tells which signals to be blocked and which signals should be allowed, okay. Okay, which signal to be blocked and which signal to be allowed. Here, the program sets its signal mask to contain sig term. So what we are adding? Okay, we are adding to the signal mask this particular signal. Okay, so this is the terminating signal we are adding to the signal mask. Okay, so this particular signal we are adding. If there is, okay, okay, then we have sig pro mask. Okay, sig pro mask will add this to the mask. Okay, this particular signal will be added. So if there is any error, it returns is -1 and it will display the error message. If there is no error, okay, moving on to the next one. So here you can see when this particular signal occurs, okay, we are calling okay, sig action. So here you can see here sig action is having action and old action field. Okay. So sig action, what is the action values we have? We are having this. What is the handler for this and what is the flag for this? Whenever this particular signal sig int occurs, okay, when this particular sig int occurs, we are supposed to call this handler, that is call me. So what is the action? It is okay, so you can see here. So in this program, we set the signal mask to contain sig term. Okay, signal mask is added with the signal, and then we set up a signal trap for sig int signal. The program then calls. Okay, after that, what we have? So whenever this particular signal occurs, we are calling this user-defined function call me. Okay, so this is our call me function. Okay, and this call me function has this long jump API. Okay, now here the program then calls sig set jump, okay, to store its code location in env, okay, global variable. So here we are storing the code location in env. Okay. So set jump call returns a zero value when it is called directly in the user program, okay, not via long jump. Okay. So here you can see here it returns 0, okay, when it is called directly in the user program, not via long jump. Okay. So here when we are going for set jump, okay, so set jump will set signal jump, okay, so when this occurs, okay, so it returns 0 and it will go for this, okay, set long jump, so it will go for this particular statement. Now here the program suspends its execution, okay, via the pause, okay, here we have pause API when the user interrupts the program from the keyboard, okay, whenever you can see here whenever an interrupt occurs, okay, from the keyboard, a call me function is called, okay. The call me function in turn calls long jump API, transfer the program flow back to the set jump function, okay. So what happens? Now here, whenever an interrupt occurs, we are calling this call me function where it is going to this long jump, okay. So long jump, what happens? Again, it transfers the control to this set jump, okay, to transfer the control flow back to the set jump function, which in turn returns value what is the return value it returns? It returns 2. Okay, what is the return value? This is a return value. Okay. So, so 2 is not equal to 0. Yes, condition is true. Okay, so it displays a message written from signal interruption. Okay, so let us go through this. Okay, so we are entering 377. Okay, so here what happens when you enter the first time? Okay, we are not setting any signal. Okay, so it will go to the else part and it will display the message written from first time set jump. Okay, so first time set jump will return. Okay, it will not return any value, it will go for the else part. Okay, next time we are going for the interrupt. Okay, so interrupt occurs. So interrupt occurs, will go for the call me function, and call me function in turn go to the long jump function, and long jump function will return the value 2. Okay, and then you are displaying this message written from signal interruption. Okay. The first time when this occurs, okay, so it will not have any return value. It will return you -1. Okay. So here it will go to the else part. Okay. So only when this particular interrupt occurs, it will call this call me function, and then it will go to the set long jump function. Okay. So the next one is kill. So a process can send signal to the related process using kill API. So it is used to send the signal to its, one process can send the signal to its related process. It is similar to the inter-process communication. Okay, similar to inter-process communication. So here the sender and the recipient process must be related such that either sender process real or effective user ID matches to that of the recipient process, or the sender has a SU privilege. SU is nothing but root privilege. Okay. The parent and the child process can send the signal to each other using kill API. So mainly for the interaction between two or more processes, this kill can be used. Okay. So here in the kill we have two parameters. So here the signal number is nothing but it is a integer value, or it can also be a constant like sigint and all. Integer value to be sent to one or more process designated by this PID. Okay, here you have to tell the process ID. Okay, to which process you want to send this particular signal. Okay, the possible values of PID. Okay, these are the possible values. So it returns positive value 0, -1, or you can have negative value for this PID. Okay, so what is PID positive? Positive means PID for the process ID. Okay, so process ID we are sending. Sending 0 means send the signal to all the process. Okay, those having the group ID same as the calling process. Okay, -1 means this is also for sending for the all the process, but this is using real user ID. Okay, here we are comparing group ID, here we are comparing real user ID. And negative value means it is also sending for the all the process, but whose group ID matches the absolute value of the particular parent ID. Okay, which is intended to send the signal. So here we can see, so kill will return, okay, on, if it is successful it returns 0, if there is any error it returns -1. Okay, kill function. So here if it is -1 then it is tell, we can tell that there is a error. Okay, and if it is not -1 that means it is successfully able to send the signal to more other process. Okay, so here what is the process ID? So here sig number, we have signal number, okay, which can be an integer number or a signal, symbolic name of the signal, okay, which is specified in this header file, that is signal.h. Okay, we have process ID. Okay, so this is a process ID. So here you can see here we have the main function. So in the main function we are taking the signal number. So here the first argument is your signal number, okay, which is ampersand sig. Okay, you are taking some signal, something like the sig term. Okay, so if there is any error it returns -1. Okay, So here like this, you can have, so how many arguments? Three arguments. Three arguments you can take. Then here this is meant for taking the process ID. Okay. So here how many process ID you can take? Three process ID you can take. Okay. Get the process ID. So how many signals you are sending? You are sending maximum three signals and maximum three process ID. For these three process IDs, okay, let us take 1, 2 and 3. For these three process ID, okay, we are sending the specified signal. Okay, the input signal you are taking, that signal will be sent to this three process. The next one is alarm. Okay, so alarm API can be called by the process to request the kernel to send, okay, SIG alarm signal after certain number of real clock seconds. So this is important concepts. Okay, alarm, okay, API. So why it is used? It is called by the process. Okay, which signal? To send this signal. Okay, after a certain number of real clock seconds. Maybe after 1 second. Okay, 1 second send the signal, or after 2 seconds send the signal. So okay, so this is for sending the signal after certain real clock seconds. So this is a prototype. Okay, so here we are specifying the interval. So this is the interval. Okay, you can specify like this, 1 second, 2 seconds and all. You can specify the interval. Now here you can see uh, this is the handler, user defined handler built-in function, wake up. Okay, and here we are having this sleep function. Okay, till here we are having sleep function, and here whenever, okay, signal alarm, whenever the sig alarm occurs, okay, whenever this occurs, okay, we are calling this, we are calling this wake up user defined function. Okay, we are calling this wake up user defined function, and inside this you can have some task to perform. Okay, which is kept empty now for time being. Okay, so whenever this signal sig alarm occurs, okay, now here you can see here we are specifying the timer. Okay, alarm timer. Okay, you can specify some value for the timer. Okay, so for every timer's value, okay, for every timer value, maybe 1 second or 2 seconds, this signal sig alarm will be called. Okay. So this alarm, so return value of this, what is the return value of this alarm API? It is the number of CPU seconds left in the process timer. Okay, how many time it is left? So So this is a sleep function. So sleep function will set up a signal handler, okay, for the sig alarm. Okay, this program is all about setting a signal handler for this sig alarm signal, okay, and calls this alarm API to request the kernel to send sig alarm signal, okay, and finally suspend its execution using pause system call. Okay, and here wake up is a signal handler function. Okay, is called every time when the sig alarm signal is sent to the process. Okay, every time when you are sending this signal to the process, okay, any process, any number of process you are sending, you are calling this user defined function. Okay, next one is, so interval timer can be used to schedule a process to do some task at a fixed time interval. Okay, so this is important. It is meant for performing, okay, scheduled task. Okay, it is used to schedule a process to do some task. Remember these words, it will be easy for to write in the exam. Okay, some task at a fixed interval. For example, 1 second. Okay, for every 1 second you call this function wake up. Okay, for every 1 second, that's an example. For every 1 second, you call this wake up function to the time the execution of some operation or limit the time allowed for the execution of some task. Okay. Now here we have different APIs. Okay, these are different APIs. Set timer, get timer, and all. Okay. So in BST Unix, so this is one type of operating system in Unix. So this is set timer API. Okay, which allows which provides capabilities additional to those of LRAM API. Okay, in addition to this LRAM API, additional functionality is there in this API. Okay, so this is LRAM signal we already saw in previous slide. It is for sending SIG LRAM signal for every specified interval. Okay, when any timer expires, okay, when any timer expires, a signal is sent to the process and the timer will restart. Okay, so get timer API. So here this is set timer API. Okay, which takes you can see here. This I will tell. Okay, this I will tell the parameters later. Next, get API, get timer API. It is also there in Unix. Okay, which is used to query the timer values. So this is for getting the information about the timer, which is set by the previous set timer. Okay. So here we have three parameter, which time interval and which is a time interval value and a time interval old value. Okay. Now here we have first parameter which argument, okay, specify which timer to process. Okay, which timer to process. Okay, so what are the possible values? Okay, there are three types of possible time values: real, virtual, and one more is PROF. Okay, this is PROF. Okay, so what is timer type? Real means you can specify this constant value, three constant values. Okay, real means timer based on the real time clock. Okay, you are setting, okay, you are performing some task, okay, based on the real time clock. So this value is a real time clock if you give this constant. Okay, so it generates tick LRAM when the signal expires. Okay, so when it generates the signal when expires, when this timer expires. And next one is based on user defined time. This is one more time which is there in the process. Okay, so this will generate one more signal that is called as this signal. Okay, when the timer expires. Last one is based on total user and system time. So this is addition of user and the system time. Okay, and this will generate one more signal. Okay, that is a sig proof signal. Okay, when the timer expires. So this is based on real time. Second one is based on user time, and third one is based on addition of user plus a system time. Okay, and the next one is a structure. So next one is a structure. Here you can see these two are, okay, struct keyword we have used. So these are the variables or the members of the structure. Okay, so this structure is defined here. So what are the structure? The name of the structure is I time, okay, time some value. Okay, this is the name of the structure. Here there are two members. Okay, these are the two members. So this first member is nothing but timer interval. Second member is based on current value. Okay, so it is timer interval. Okay, and this is the current timer value, current time value. Okay. Here we have it value, okay, first I'll discuss about this. It underscore value is a time to set the named timer. Okay, so this is current value you are setting. Okay, for example, you want to send it for every 9, okay, 9 o'clock. Okay, some example. Okay, and this structure member, okay, it's a time to reload the timer when it expires. Okay, for example, reload every time, when to reload, okay, when to reload the timer, okay, when the timer expires. Okay, so here this if interval, okay, this first one value may be set to 0. Okay, this value can be set to 0. Okay, if the timer is to run only once. Okay, if you don't want to refresh the timer, if you don't want to reload the timer, what you can do, you can set this value to 0. Okay, otherwise you can tell for every, okay, 24 hours just refresh the timer. Okay, so you, this timer can be refreshed for every 24 hours. Okay, so that's an example. And here this value is also can be set to 0. Okay, so if it is set to 0, it stops the name timer if it is running. Okay, so here also get the timer. So get the timer is, okay, this value you have to specify, and here old interval values. Okay, so there is an example. So here, so here we have alarm. Okay, what is alarm signal? What is the interval? It is 5 second, 5. Okay, it is in terms of microseconds. Okay, it is not the seconds, it is microseconds. Okay, this interval is in microseconds. So for every 5 microseconds, okay, for every 5 microseconds, you are calling this function sig LRAM. Okay, which in turn, whenever the signal at LRAM occurs, you are calling this. Okay, in turn, you are calling this function call me. Okay, this is a handler, and handler, okay, he is here, that is call me is here. Okay, what this call me will do? Okay, it will do some scheduled task. Okay, again it will call this alarm interval. Okay, for every again 5 millisecond, again this continues. Okay, so every 5 millisecond, first the signal alarm occurs, which in turn calls the call me function. Again this signal, okay, we are calling this alarm signal. So in the above program, the SIG action API is used to set up call me a signal handler function for SIG alarm signal. Okay. So here we are sending SIG alarm for every 5 real clock seconds. Okay. So here the program then goes off. Okay. So for the program will perform some normal operation. Okay. So here you can see for every infinite loop while is equal to 1, okay, we are performing some normal operation. Okay. Then when the timer expires, okay, when the timer expires, the call me function is invoked. Okay. So every 5 seconds, okay, at the end of 5 seconds, you are calling this call me function, which restarts this LRAM again. Okay, for every 5 seconds, 5 microseconds, and then perform some scheduled task. Okay, so this is an example showing this alarm, okay, alarm API. And here you can see set timer and all. Here you can see. So set the timer, what we have here, the interval is 2. Okay, so this is the interval. So this is, if you see here, this is similar to your previous program. Okay, but only thing is here we are using, instead of alarm we are using this API. Okay, set I timer API instead of alarm API. So here there is no need to call set I timer API inside the signal handling function. Okay, here you can see here we are not calling any alarm or any set I timer API, but here we are doing what? Again we are calling every 5 microsecond. Again we are calling alarm, correct? But here we are not calling again set timer. Okay, inside the signal handling function call me. Okay, as a timer is specified to be reloaded automatically. So what happens here? The timer will be reloaded automatically. Okay, so here what happens? Every 5 seconds again and again you have to call the alarm, but here it will be reloaded automatically. Okay, so here what happens is, this is based on, there are two parameters. Okay, this is real time clock. Okay, real time clock, based on real time clock. And here we are having, okay, value, okay, seconds, that is based on 2. These are the values is 2. So here till here you have some your user defined function. Okay, so this is your main function. So every time this, every, okay, every uh, real time, based on the every real time 2 microseconds or 2 seconds, okay, we are calling this function call me. Okay, call me function, and it will whenever, okay, first the signal occurs. Okay, this will signal will be called automatically, and which in turn calls this call me function. Okay, and this timer, okay, we are not calling again and again to reset this timer for every 2 seconds. Automatically this timer will be reset. So next one is the POSIX 180 timer. Okay, so this is one more timer similar to the previous one. The previous one is interval timer. Okay, so these timers are more flexible and powerful compared to any Unix timers. Okay, so user may define multiple independent timers. So this is one advantage. Not just one timer, you can define multiple independent timer per system clock. And every timer is specified not in microseconds but here in terms of nanoseconds. Okay, so here we are specifying in terms of nanoseconds, and user may specify on timer basis. Okay, on timer basis, a signal to be raised when the timer expires. So this is similar to the previous one. So whenever the timer expires, a signal should be raised. Okay, the time interval may be specified as absolute or relative time. Okay, so any time can be used, absolute and relative time. So these are the two different types of times related to the process. Okay, there is a limited on how the POSIX timer can be created per process. So here we are using a constant called as timer max. Okay, which is defined inside this header file. Okay, so So this will tell, okay, this timer will tell, okay, how many POSIX timer can be created per process. Okay, so how many timer? Okay, how many timers? I said there are multiple independent timers can be created. So how many timers? Okay, So that is specified using this constant timer max, okay, which is there inside this. Okay, and there are different APIs. Okay, first one is timer create. Okay, so this is dynamically create a timer and return its handler. So this is for creating the timer. Okay, here what are the arguments we have? Clock arguments. Okay, so this is clock arguments. Then we have here we have, so this clock argument can be a real time, okay, a real time clock value, okay, and we have one more structure. The name of the structure is sig event. Okay, this is a structure, and for that structure we are using the member of the structure. Where is the structure? It is here. Okay, this is a structure. So this is a clock value which can be specified in terms of real clock value. Okay, your system time can be specified. And here this is a structure sig event. Sorry, this is, yeah, sig event. Sig event has got three members. Okay, so these are the three members. So this is this uh, second argument. Okay, the second argument defines what action to take when the timer expires. Okay, when the timer expires, what action to perform. So this is given by the second argument. Okay, so here we have signal. Okay, so the first there are three members. So first we'll discuss this signal number. So signal number field specifies the signal number to be raised at the timer expires. Okay, it is valid when okay you are using this member. Okay, and this member should be set to this value. Okay, so this will tell what type of signal to be raised. Okay, but this value should be set to this. Okay, sig ev signal. Okay, this is a built-in value. Next one is sig notify field, which is set to, if it is set to this, what is that? No signal to be raised by the timer when the signal expires. Okay, if this signal notification is set to this value, then no signal to be raised. Only if you want to raise the signal, then the value of this signal notified should be equal to this. Okay, so two values it can take, either this value or it can take this value. Okay, so this is for no signal, this is for raising the signal. And next one we have signal value here. Okay, that field is used to contain any user defined data to identify that the signal is raised by the specified timer. Okay, so here it will be having any user defined data. So user defined data will be there here. Okay, this. Again, you can see here, this is a union. Okay, inside the structure you have a union. So here this is a union, it is specified. So this is the name of the union, sig value. There is a lot of things to remember. Okay, so these are signal APIs, their prototype, everything you have to remember. Okay, so here sig value union, there are two members. Okay, these two are the two members. So here first field is sig value int field. Okay, so this is nothing but the signal number value. Okay, and here we have a pointer. Okay, so this is a pointer, and finally, okay, there is one more argument, that is timer HRDP. So what is that? It is the third argument is an address of this timer T typed variable to hold the handler of the newly generated timer. So what is this? This is the address of the handler, that is user defined handler, okay, like our caller or wake up, okay, handler function. There are three parameters. One is clock. This is for giving information about the action to be taken when the timer expires. And this is what function you have to call when a particular signal occurs. Okay. So next one is timer set time. So next one is this set time. So set time, again it has three, okay, four arguments. Okay. So first argument, it is about handler. Okay, what type of handler, what type of function you have to call when a particular signal occurs, and the particular different types of flags. Okay, and again here we have different values. So this is set timer API. It is used for starting and stopping the timer running. Okay, anytime you can start the timer, okay, and stop the timer by using this. Okay. Next one is get time. So get time, as the name tells, it is used to get the information about the current timer. Okay, it is used for getting information. So here you can see, so this is, okay, about the structure of the structure. Okay, here it is defined here. So there are, okay, you can see here, this is the main structure. Okay, any disturbance?
बोले
So here we can see there are two types of structure here. Okay, so one structure is here, struct IT. Okay, so that is defined here. Inside that you have one more structure with the name timer spec, which is defined here. Okay, so these are defines different values. Okay, so flag will tell you, okay, uh, it will be set to 0 or it will be set to this value. Okay, when to start the timer and when to stop the timer. Okay. So it can also be set with this value timer ABC time. So this is for real time and this is for absolute time. Okay. And here you have old. So old argument is to obtain the previous timer value. Okay. So suppose if you have stopped the timer at certain point, okay, so that can be specified here. Old timer value. Okay. If no timer values are written, so old argument of get timer. So here also you have get timer old argument. It returns the current value of the named timer. So you can give here, okay, timer value, okay, which will give you the information about the timer. So the next two functions. So this is to get the create the timer. This is to set when to start the timer and when to stop the timer. And this is to get the information about the timer. And you have two more. So one is get over run, okay, and one more is timer delete. So what is get over run? So it returns the number of signals generated by the timer, okay, but was lost. Okay, how many signals have been generated? Okay, question mark. So kernel records number of overrun signals per timer. Okay, so per timer, how many signals are generated? So that will be that you can get the information using this. Okay, this is to completely destroy the timer created by this API timer create. Okay, so this is all about timer. So till here you will be having for your second internal. Okay, till here. Okay. your complete third module and your fifth module. Okay, remember we have started with the fifth module. Okay, this is your fifth module. Fifth module till here you will be having for the third internal. Okay, next is demo process. We'll continue in the next class.